Hi everyone, today we'll be talking about rationalizing the denominator. It essentially means simplifying expressions, like simplification of expressions as it is written here, right? Um, we simplify such that there is no irrational component in the denominator. Um, to give a very quick example, if you have something like x is equal to 1 by root 3, right? You see that the denominator here is irrational and we want to rationalize x where it is 1 by root 3. So what do? We multiply it with a factor which helps us bring it into a rational form or in a better simplified expression. How do we do that? We multiply 1 by root 3 with the same irrational component. So like if I multiply 1 by root 3 into root 3 by root 3, root 3 by root 3 essentially being 1, it will become 1 into root 3 by root 3 into root 3, right? And if I continue this, it will become root 3 by 3. And now this is a simplified expression. Now, why do we need this? It's just a general habit in mathematics, and it's just a general way of doing things that we don't really keep the denominator in an irrational format. So just to make things in a particular format where everybody follows a proper convention, we just follow this rationalization principle. The values, whatever you will get, it will be the same. So like if you started with x is equal to 1 by root 3, root 3 by 3 will also give you the same answer, right? So you are not changing anything, you're just representing this one number which had an irrational denominator into a new format which is generally asked, right? So another way that we rationalize numbers is that what we can do is we can multiply it with a conjugate. Now what is a conjugate? So let's say there's a number called, there's something called 2 minus root 3, right? What is the conjugate of this? So this is a binomial expression. When I say binomial, I mean two terms, right? Two terms means binomial, right? So two terms, a binomial expression. What is the conjugate of 2 minus root 3? Well, as the definition states on the left hand side, a conjugate is formed by changing the sign between two terms in a binomial. So if I have a minus b, its conjugate will be a plus b, right? If I have b plus c, its conjugate will be b minus c. I just change the signs, right? The plus becomes a minus, the minus becomes a plus, right? So going with that, if I have an expression which like says 2 minus root 3, I'll just multiply it with 2 plus root 3 and 2 plus root 3. So this will, once we solve this, this will rationalize the expression. All right. Now, why cannot we multiply this 1 by 2 minus root 3 with root 3 by root 3 to rationalize it? I mean, in the first example, we did the same thing with 1 by root 3. We multiplied it by root 3 by root 3. We rationalized the denominator, right? But why won't it work here? Now, if you solve it, you'll see that we'll get root 3 in the numerator, but in the denominator, we'll get 2 root 3 minus 3. This still is an irrational number, right? But our objective was to remove irrationality from the denominator. That's why we started rationalization in the whole place. So, in the cases of a monomial expression, when a monomial being a single term, let's say root a, 1 by root a, you just multiply it by root a and root a, you rationalize the denominator. But if it's a binomial term, like 1 by 2 minus root 3, you have to multiply it with its conjugate. And the conjugate being that is formed by changing the sign between two terms in a binomial. So if it's a minus b, it becomes a plus b. If it's b plus c, it becomes b minus c, right? The sign changes, and that's how you make the conjugate. Now, in this segment, we'll be solving two questions, and one question will be showing the rationalization factor, which we discussed, and the other one will be talking about the conjugate. So we'll see how to solve both kinds of questions and how to proceed with them in different question types. So the first question is rationalizing 2 by root 3, if you can see on your left hand side of the screen. So I'll just rewrite it. It's x is equal to 2 divided by root 3. Now, what is the rationalization factor here? Since it's a single term, we don't have any other thing. If we just multiply this expression with root 3 in both the numerator and denominator, it should retain the same answer and change the representation of the expression. So let's move forward with that. It will be 2 by root 3 into root 3 by root 3, right? And this becomes 2 root 3 into root 3, and this will be simplified into 2 root 3. Root 3 into root 3 is 3. So this becomes my final answer. And if you see, we have successfully rationalized the denominator, which earlier was 2 root 2 by root 3. Now it is 2 root 3 by 3. So now this is an expression which can be said is the final answer rather than saying 2 by root 3 is the final answer, right? Now this was when we used the rationalization factor for a monomial term. Now if you move on the right hand side, we have a question of x is equal to 1 by 3 plus root 2. Now if you remember, we talked about what will be the conjugate of a plus b. We just need to switch the sign. It will become a minus b. So here, if I want to rationalize x is equal to 1 by 3 plus root 2, I just need to multiply it 3 minus root 2 to both the numerator and the denominator, right? So let's just do that here. 1 upon 3 plus root 2 into 3 minus root 2 into 3 minus root 2, right? Next step would be numerator will become 1 into 3 minus root 2. It will be just 3 minus root 2. And denominator will have to multiply 1 by 1. So 3 into 3, 9, minus 3 into minus root 2. 3 into minus root 2 will be minus 3 root 2. Then plus root 2 into 3, it will be plus 3 root 2. And then plus root 2 into minus root 2, it will be minus 2. So plus 3 root 2 minus 3 root 2 cancel. We are left with 3 minus root 2 divided by 9 minus 2, that is 7. Now see, my denominator now is rationalized. I don't have 3 plus root 2 in the denominator. It's a rational number 7. So this is my answer.